Right, so I look to get a show here. So this class we'll be going through some of the basic stuff that you all need to know, and then we'll be continuing from there, right? We're holding way up, so if you have any questions, you can ask or just see it in the chat. So from what I said last week, remember there are three forms of the Fourier series, right? Technically, I see it as two because the last form is not really as popular. You just need to know that it exists and how to get to it. Right, but if Miss bringing a question, she normally brings either the first two. She rarely brings the last one. So that's good true. So the first form is the trig form, which most of the time you'll be working with like 70% of Fourier. Not your final exam, 70% of Fourier. So the form of it is f on t, which is a periodic signal. So a naught on 2, DC component. Anytime you see a naught or any a naught on 2, is the DC components. Is a naught on 2. So a naught is not a DC component. A naught on 2 is a DC component. So you have to remember that. Right. Plus the sum k is equal to minus infinity to infinity. AK cos. AK always goes with cos. And BK always goes with sine. You see the importance that as you do more questions. Right? And then plus some k, so minus infinity to infinity of BK sine 2 pi k f naught t plus theta. Right. So this is the trigonometric form of the Fourier series. Right. So this is a DC component. This here, it has used this for, so it has different types of signals, right? So it has an even and it has odd. We'll get to an up. So depending on if it's an even or odd signal, one of these, either the sine or the cos, drops off. Yeah, so it's kind of like drop off in when you're doing the actual question, which is the graph form, right? But just know this entire thing here is your Fourier series in the trigonometric form, and according to if the signal itself even or odd, one of them will drop off. That's what I had to catch from it. Right? The second form is the spectrum form or the harmonic form. There's the form you will use when you're actually doing the spectrum. So same thing as before, f of t, a naught on 2 plus ck cos 2 pi k f naught t plus theta k. Right? So that's your harmonic form of the Fourier series. They use this form for spectrum. Always remember, spectrum. So there's the form you need to go through to get spectrum. And this form gives you the single-sided spectrum. So you have to remember that. Right? And then the last form that you will need to know is the exponential form. So same thing as before, f of t. So the sum k is equal to minus infinity to infinity of x of k, which is your Fourier coefficient, to the power j 2 pi k f naught t. Right? Where k, x, k, that's the equation for that one. So 1 on t, integral from t to t plus t0. What this means is you're always integrating across a period. So t is where the period starts and up to t0 is where the period ends. So anytime you see us write t to t plus t0 any form of it, it just means over the period. Yeah, because it's a periodic signal. So it's had to be over a period. And you can pick any period you want. Hence why she said t and a 0. Pick any period you want. They really matter which. Once there's a period of the waveform, you get through. Right? And it's E f of t by E to the minus j x, question in the chat. So I saw she had for the harmonic theta also. Theta, she had for the harmonic minus theta also. So, okay. So remember, when you're doing the harmonic form, right? This, assume you're talking about this part here, the plus theta. Talking about that part. This part here. Yeah, sorry. So remember this cool, remember that's finished, just and I'll show you, right? So e to the minus j 2 pi k f naught t dt. Right, so I'm telling you, you have to know all these forms, like the back here, you must know all of them. You must know the equation for them. You have to, right? That's very important. And finally, you use the exponential form to get the double-sided spectrum. Have an easier way to get the double-sided spectrum without going through the exponential form, but most of them use this to get the double-sided spectrum, right? With respect to the question that the guy asked, remember cos is an even function, right? So right now I have cos x, and with the cos x, I have cos 2 pi k f naught t plus theta k. But remember cos even, so I could also have cos minus x. Remember, it's literally the same thing. Remember, if I throw the minus outside, it can't disappear. So basically, these two things are technically equal under the law of cos x being the same as cos minus x is a law. So basically, if I was to put the minus inside here now and multiply the two, I will end up with the cos, and I'll end up with a minus theta k, yeah? And I'll end up with a minus 2 pi k f naught t. So what happened with this here? If you had a spectrum for the phase, and let's say it was going up like this, for the positive part, if you do the flip of it, you just end up with the spectrum being here. Two things happening here. One, your frequency is negative, as you can see, because the minus here, and the phase flipped, as you can see with the theta here. So you're just basically representing it in a different way, but you don't really use that form. It's kind of rare to see that form because practically you can't technically have a negative frequency. So this form here is rarely used. Yeah, but the reason why you had the minus by the theta, okay, which you could have if you just use this rule here with the cos, with the minus x, multiply throughout, you get a minus for your theta, okay, and minus for your frequency. So that's gonna happen with the same graph, just flipped. With the frequency is negative now, and the phases inverted. Yeah, so you could technically get the negative, but you don't really use that form. Yeah, you don't use that form too much because you want the frequencies to be positive, right? So a negative frequency doesn't technically exist. It's like having negative money, right? It's not real. Yeah, so anyway, so back to what I was saying. You need to know all these three forms, especially this one. I'm gonna tell you something. This question in the final exam, it will come. If it doesn't come for the midterm, it will come for the finals. And if it doesn't come for the midterm, 100%, it can't come for the final. This question tests everything in part, literally every single thing. Integration, calculating equation of a line. It comes for a lot of marks. So you have to know this form inside out, right? The harmonic form, you will only use this if she asks you for the spectrum. So even if you have the trigonometric form of the Fourier series, you still need to convert it to the harmonic form to get the spectrum. So that's why this is the spectrum form of the Fourier series. Even if you had the exponential form, you could plot the spectrum with the exponential form, you would just end up with a double-sided spectrum. right? But if you're in a trig form, you have to go to the harmonic. So that's the second thing I wanted to go through. So if you add the trig form and you want to get spectrum, so the thought process is the harmonic form have everything in terms of cost. And from last week, remember, when you want the spectrum, it have to be in terms of cost, positive and cost, right? So the easiest way to get everything in terms of cost is to express it in the harmonic form. Because the harmonic form, it literally only have, or only in terms of costs. So you get through. So the first proof that you need to know, and it will come in your midterm, and if you look at the tutorial, there's one of the questions that you need to do to go from the trigonometric form to the harmonic form. And you need to know this even if you're doing one of the questions in the past papers, because if she bring a graph, when you do the Fourier analysis on that, you'll end up with the trigonometric form of the Fourier series. Yeah? Then you'll have to convert that to the harmonic form because you'll have to get the spectrum. So this here is one of the most important proofs that you will need to know to actually get a good bit of your marks. Right? So that's just very good trick. And it's fairly simple. I'll try to break it down as much as I could. Right? If you're confused, you could always put it in the chat or when I see the one in the chat, I'll check it. It does not be pop up. Right? So, okay. So the first thing you have to start off with, and you have them right, when it in the trick, so let's write a short trick form. So you have, I'll leave all the summation sign for me. So AK cos blah 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 plus BK sine blah 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 blah. Really care about it, right? The things I have to use to go from the trig form into the harmonic are your coefficients of cos and sine. So this AK and this BK. When you pull it together, it forms a triangle, right? So I don't know if you all remember from vectors, your cos is normally a horizontal component and your sine is normally a vertical component. So if you use that same thought process, you can actually get a triangle, which is the basis of the conversion. That is the first thing you had to show. Once you have that, you could get everything else, right? So let's try. So you have the horizontal, which is your AK, because AK and cos is the horizontal component, and BK is your vertical component. Put the vertical here. So that is BK, right? And obviously we know when you do Pythagoras theorem, you end up with the shortest distance between the 2 points. And this point is CK. That is where they got the CK in the harmonic form. That is where it came from. Right? So therefore, with that said, you could express in using Pythagoras theorem that CK is the square root of AK squared plus BK squared. Why? Remember Pythagoras theorem, CK squared, which is the hypotenuse, is the sum of the squares of the other two sides. So I break that down, this sheet. So all they did is just make CK the subject of the formula, and that is where they end up with this here. All right, so the hypotenuse is the sum of the squares of the other two sides, which are AK and BK. All right, so that's where they got that from. So that's the first one. That's the first thing you had to know. Secondly, obviously it has an angle. So the angle is theta key, which is where they got the phase from. Right? We could get the equation for theta key because we soak out to one, so we could use it. So this here is the opposites, and there's the adjacent. You're assuming that you don't have C. All right. So that is tan. So you're gonna put tan theta k, and that is O A. Yeah. And then you make theta k the subject of the formula, so you end up with tan inverse. So when the characters, the trigger will switch to the inverse, BK on AK. Right? And then for this proof, something I have to remember is for derivation purposes, theta k will be the same as minus theta k. So you just have to use the minus. That is only for derivation purposes, just to make the derivation easy, right? So this, a lot of people just forget this part. So like two. So you have theta k, you have ck, right? So the next thing you'll have to do for the proof, right? You get marks for all this, huh? You get marks for all this. So the third thing, in the equation itself, you have an equation for cos theta k and sine theta k. Remember, in the trigonometric form, you're trying to replace most of the other stuff with it, as you'll see in a bit. So the first thing you'll want to have is something for cos theta k and sine theta. You'll see the importance of this one when you do the proof. So cos theta k, normal SOHCAHTOA. So cos is adjacent on hypotenuse. So the adjacent is AK and the hypotenuse is the square roots are AK squared plus BK squared. And sine theta k is so it's opposite on the hypotenuse, which is the same AK squared square root of BK, right? So you have those four things. So those are your first four things that you calculate. So you draw a circle, marks, you show what CK is, square root of AK squared plus BK squared, marks. You don't need to write this. So I'll just erase it for now. That's really not needed, right? Then you have to show the equation for theta, okay? And remember this rule. Next, we end up with the minus. The actual equation for phase is minus tan inverse. So theta k is actually just minus tan inverse bk on ak. So the big mathematicians sat down and they did their long process and they came to this conclusion. So I'm not going to fight with the mathematicians. So we have those four things, right? So now we can actually study derivation. So I'll go on a new page because of space, but I don't want to jump too much. So remember, we started with the trig form of the Fourier series, right? So we have f of t. You know, onto the DC component, that's not going to change if you swap forms because it's just a DC. So I will state it. So you have plus, for now, I'll leave out the summation. So you just have your AK cos 2 pi k f naught t plus theta k and a bk sine 2 pi k f naught t plus theta k. Right. So we want to write what we had on top, these things that we calculate here. We want to use it in the proof, right? So that is really what we're trying to do at the end of the day. But while we're doing it, we have to write it. We have to kind of manipulate the equation in a way to get what we have. So you kind of like had a, as Mr. say, massage it a little bit. So what we could do in the equation is multiply by 1. So when you multiply it by 1, right? So we want to end up with something for AK and something for BK in terms of 3 and 4, which is these things here. That's what we want. So basically, if you think about it, all I want to add is this denominator here. Because if you look at the form, the AK and the BK already there for me. So something you could do is multiply by 1. So when you multiply by 1 is 1 on 1. Because this here doesn't change the overall value of anything. So if I also multiply this by x, this is going to cancel. If you try 2, it's still going to cancel. You could try infinity and infinity, it's still gonna cancel. So that's what I mean by multiplying by one. It doesn't change the overall value of the actual thing in question. Yeah, but what it does, it kind of gives you the ability to add components to the question without kind of changing the value of the question. So it's a cool skill to have, multiplying by one. So you see how this will come in handy in this question. So what we could do is multiply by one. So our one in this case will be what we're trying to add in. So your one is always what you're trying to add in, right? Because obviously besides the part that you will be missing because you already have this. So and you already have the equations for them up here. So all we can do is multiply by one. So when you multiply by one, is you kind of like multiply it by this. So you kind of multiply by AK squared plus BK squared. And it's the same thing over and over and over and over and over and over. Right? So when you go through that piece of the derivation, you just end up with A naught on 2 plus AK squared plus BK squared, and you have the cos. And you just end up with the same thing for BK divided by what you wanted to add. Right. And the sine of 2 pi k f naught t plus theta k. So right now we add something, but we have to remove it at the same time. So the A naught and 2 will stay plus, but we're missing something here. Because if we leave this here, if you look at it carefully, this is not this, and this is definitely not this. So what you did there is change the value of the question. So what I could do to negate this change is just multiply by the same thing I added. So now when I expand the brackets, if I were to, I'll just end up with what I had before. So technically, I didn't change the value of the original question. So I inadvertently just multiplied it by one. So you just add where you want and remove it. Yeah, so you're adding it, but you're also writing something that will negate it at the same time. So it wouldn't change. It would cancel, and you just end up with what you had before. So we have this, right? That is all that happened. Nothing else. We just multiply by one to get something in terms of the square root side, which is CK basically. Right, that's the first piece. Nothing else happening there. So now all you need to do is you can kind of simplify it now, which is basically what we did from before. This is something we did just now. This piece here is 3, and this piece here is 4, which is why we did the triangle thing there. So we could say A naught and 2 is T, because it's the DC component. This is CK, right? And then this here, if we go back, I was cos theta K, right? Now what you write back the 2 pi kf naught T plus theta K, right? Then you have this here, which was sine theta K from the triangle. So that's plus sine theta K. Now the 2 pi kf naught T plus theta K coming in at the end, close that bracket, close the break bracket. So right now we almost there, but we have one problem. We have a set of madness in this bracket. So we have a product going on here. But the thing is, we have a trig ratio that we could use. So I'm gonna give it in context. We're trying to get the harmonic form. So we have the A naught and 2, good. We have CK, which is part of the harmonic form. So somehow this madness inside this bracket somehow had to boil along to give me cos 2 pi k f naught t plus or minus theta. Somehow it had to give me this, or minus if you want to write it like that. So you might be looking at that and be like, well, oh, this is a compound angle, right? So this is one of your components, which is one, probably four of the most important equations you have to memorize in this course and in 2001, right? This here is a trig ratio. You're probably looking familiar, but it's the compound angle. So plus, when I have a plus, remember, because when you start, you just have the opposite of it, right? So this here is actually just cos A minus B. That's all it is. We're just going to boil down to this. So when you do number letters, as you see when you do some questions later, the entire thing in the bracket is the letter. So this entire thing here is A, right? And this entire thing here is B. Think of it like or A, B, any way you want to write it, which is where the plus and the minus has come from. Because depending on which order you put the B and the A, you could just end up with a different sign. But let the theta K be A and this part here be B, right? And the same thing, on this whole thing here is B. And we have A. So it's like saying cos A, cos B, plus sine A, sine B, which is basically what this thing is here. Cos A, cos B, and you have plus sine A, sine B. So that's literally what you have here. Yeah, it's literally word for word exactly what it is here. So as you do more questions, you will tend to get accustomed to it. If you see cos by sine, that is a trig ratio. That is a compound by sine. If you see cos cos or sine sine, that is a compound angle for cos. So if it's same as cos, if it's different as sine. Right? So breaking it down now, final form. So A naught on 2 plus ck. So now we could break this down. So cos. So A is theta k minus and B is madness inside. Make sure I'm per bracket. Madness inside our bracket. Right. They have this piece here, you could probably leave out the yeah. So you have this going on here. All right. So when you reduce this, so obviously you don't want the minus here. So you kind of want to factor out the minus out of this before you do anything. Because remember, cos even, and you don't want any negatives in here. So you could just factor it out. So you end up with minus theta k, and this just going to turn to plus. All right, and then when you rearrange it, so you end up with the frequencies positive, and then the phase negative. So this here is what Miss was talking about. Is what I think when what the person asks. This was the form Miss was talking about. So when you actually do the derivation, you'll actually end up with it in this form because of how you use the trig ratio itself. Right? And you can probably try it. If you also use theta k as B and this part here as A, you'll actually just end up with the reverse and you end up with the positive here. So you could try it out if you want. But all in all, that is the end of that group. So that's a recap. Straight from the top, you start with your triangle. So remember the triangle AK, BK, horizontal, vertical, CK is Pythagoras theorem. So you just end up with this nice equation here. First one done. This part here you could show is not as integral to the question, right? I'll show you how this can come in just now. Then from there, once you have the triangle, right, and you get CK, which is your most important thing, you just get cos theta k and sin theta k, which is these equations here. And once you have that, you could just jump it. So you just write out the trigonometric form, and you're trying to get AK and BK in terms of what we used from before. So you multiply by 1. So all it is, just write where you want it to be under, which is the square root of AK plus BK squared on both of them, and just multiply by it outside. Let's don't forget that piece. Okay, if you don't put that, it will change the entire value because so then this part is CP, and this is where you want to use the tricks. We're trying to work up to the compound. So where the substitution, there's cos theta k, and this is sine theta k. So yeah, we put this form here, and this is just a compound angle in its simplest of form. Let's remember everything inside the bracket, treat it like one letter. Right? Don't split up this and this. It's one thing. It's like x. Cos x, this entire thing here is x. Everything inside the bracket. Because the x also in our bracket. Right? And I just the compound angle. So what I just do, I just write the letters on top of it like this. So I will know what it is. And then I write the trig ratio, like this here. And then just write in the values after. Right? So in this form here, you factorize the minus because you can't have negative frequencies. Yeah, so I don't want this negative here. This negative was our problem. I don't want my frequencies to be negative, right? So from the time I see that, factorize the minus 1 time. And if obviously when I carry the minus outside, it could just blink, right? So this part here now, let's do that part again. So when I factorize the minus, this will go to a minus, and this will go to a plus. Oh yeah, so when I carry plus a minus outside here, you end up with a plus in a minus. Wait, yeah, so this is the form. Because remember, when I get this minus, we had factorized the minus out of this here. So minus out of that, I get minus. Minus out of that, I get plus. So the minus being factorized out of this here. So you get the minus here, because cos a minus x is just cos x. You end up with this here. So that will also be positive, but not negative. Right? And that's what I said before. Because theta k is the same as minus theta k, because of what we did on top, you could always just swap this for the minus, which you would really use. So you really had to worry about it. Trust me, don't have to worry about it. Honestly. Because that's something to, when you do any questions, you're ready to see. Right? And that is the another proof. That's like 15 marks. If Miss brings it 5, 10. So now we bring 2. The trig to the harmonic and the trig to the exponential form. Should I go in the opposite direction? Thankfully. So the questions on the tutorial is where I had those two proofs. Now that is where this proof will end. Very important. So that's to wrap up everything we had to remember is anytime you're in the trig form and you want to get the spectrum, just CK as the square root of your AK value squared plus a BK value squared. And when you want to get the phase spectrum, which is your theta k's, I just minus tan inverse of BK and AK. Basically, that is the takeaway. An exception of the proof, even if you don't know the proof, you have to know this regardless. Yeah, but doing the proof will kind of show you how they got these things. So basically, what changed is I end up with the CK, which is the square root of AK squared plus BK squared. And you just end up with the cos, which you can easily use to get the spectrum. All right, so that is that. You have any questions on any single thing I do from this page? Anything. It could be how small, anything. So I'll just assume I'll catch it. Right? So I'll send this document with the stuff on it. And you should have the what is that? I'll send it to you. I'll take that as an so try to break it as much as I could. So you should be able to see that. Sorry about this mistake here, I don't see Yeah, I think I rectified it, so good thing I saw it. Right, so let's go. So we start any questions. So my advice to you is get a piece of paper, like a page or a book, and just write trig ratios in that alone. So anytime you do in Fourier in class or whatever, just have it there. Because she go always braid behind your back. Where's sine, A, cos? She would always ask you. So you could just have it there and be like the smart child in the class. Yeah, she go like it. Because most people don't remember the trig ratio from C-section. Yeah, because I didn't remember. Because they never use them after that. Right, so I'll start easy and I'll build up to it, right? So there's our introduction, spectrum, so you can get accustomed to it. Then next week we'll do the graph ones, which is the one with the equation, the line and whatever. We will do going from the trig to the exponential and so on and so forth. So you can actually see how we could actually go through the different forms of it. And you'll actually notice how inefficient some forms are based on where you want. Because remember where you want a spectrum. That's where you want. You want to break down every single signal to a spectrum. And what's the best form that you could use to get a spectrum? The harmonic form. Because you could go from the harmonic to the double-sided. Remember, the harmonic gives you the single-sided. And you don't have to go to the exponential form to get the double-sided. You don't need to. But what you could do, you could use the harmonic form, which gives you the single-sided spectrum, to just go straight to double-sided without going to the exponential form. Right, but anyway, let's start. So it's that easy. Concepts, or braid concepts. So remember it, and we'll go through. So very easy. So we have 5 cos 4 pi, so, sorry, 400. I'll look at questions here. So 400 pi f naught t plus 90 degrees. So we have this here. So I'm literally breaking it up here, right? So the first thing, well, I just look at, remember the form of the harmonic. So this in the harmonic form, right? So you have ck cos, and technically in the trig form. So you have to remember the trig form and the harmonic form. If they give you something in cos alone, it technically in the harmonic form. Because remember the trig form, it has cos and sine. And the harmonic form is just cos. So technically this here is already in the trig form and it is already in the harmonic form. Yeah. So if that give you sine, however, this will be the trig form. It will be in the trig form, but it won't be in the harmonic form. Remember, the harmonic form is only cos. So you'll have to go and convert the sine to cos, and then it will be in the harmonic form. But something in terms of sine will be in the trig. And always say if it has sine and cos in the trig form, but it's not in the harmonic form, because the harmonic form is only cos. Yes, so you'll see that. Trig is cos and sine, harmonic is just cos. So this here is in the trig form, and it's in the harmonic form. But the form it's not in is the exponential form. Because the exponential form don't have cos and sine. So clear as day. So first thing is what form it's in. So this in the harmonic form, so I get through. Remember, I want spectrum. If I write in the harmonic form, that kind of make my work easier. Because as the form I had to go to anyway. So the second thing, right? I'll look for, and remember inside the bracket, you must have 2 pi kf naught t. Yeah? Now, plus your theta field. So this is the form they need. So right now you must have a 2 pi, but kf naught is the harmonic frequency. Kf naught is the harmonic frequency, right? K just is the scalar multiple, 1, 2, 3, 4, whatever. All right? So right now that not in that at home. This is our problem. Cannot work with the letter. So I must factorize the 2 out of this. So I do that part now. So you end up with 5 cos. So 2 pi, 200. So 200 is kf naught, which is a harmonic frequency of the signal, you already know what the signal is, plus 90 degrees. Yeah, nice. So we have that in that form, all good and well. The third thing I look for is if it's a sum. So what I mean by if it's a sum is that the number outside the cusp, which is basically number here. If it's negative, there's a problem. Remember, it's a sum of sinusoids. Yeah, remember that it's a sum. So you have to convert this minus cos, because basically it's just a minus cos to cos. Yeah, you have to be able to do that. Yeah, look for that. So you have to convert the minuses to pluses. Yeah, yes, you have to look for that. Look out for them kind of thing. So luckily for us, it's positive already. So can I make our work easy or so good? Positive. Check. It's 14. You can just get the spectrum because you pass all the levels that you need to go through in order to plot the spectrum. Good. So you check the form. Luckily for us, it's in the harmonic form, which is good. So that means it's in cos. So what I mean by if it's in the harmonic form, it already in terms of cos. Come on, but when you're trying to get spectrum, you're trying to get any cos. Kind of like going to repeat that an infinite amount of times, right? That'd be any cos form. So it already in the cos form. So can I get through? If it was in the sine form, me had to get any cos form. Yeah, which is a shift, as you see when you do the question. Then check to see if the 2 pi factor is inside the bracket. Luckily for us, it wasn't, so we had to factorize it. So I show that here. So we get the 2 pi, 200 is the kf naught, which is your harmonic frequency, and you have a phase 90 degrees. Sum, luckily for us, it didn't have a negative, and we go ahead and get the spectrum. So we start with the magnitude. So this will be the single-sided spectrum, right? So we know the frequency is on the x-axis, and you have your magnitude. So because we know what the harmonic form is, we actually know what on top here, different from last week, it's CK. Because we know what the form is, you know what the coefficient of the cos is CK. Right? So I don't need to put mag today, I could just put CK. So what harmonics do we have? It's just 200, just one harmonic. So just have one spoke at 200 hertz, and it goes up to 5. When you're plotting the spectrums, write the number on top of the spoke. Don't write it on the x-axis, because that could get cumbersome real fast. And how does it check over? Right? So let's say put 0. So what miss gives you marks for? When you're drawing a spectrum, labeling the axes, so frequency, CK, labeling the frequency, and the spoke. So make sure you have all those things done right. And while I'm at it, I will just show you all how you can just go from the single-sided to the double-sided one time. Just some simple. When you go into the double-sided from the single-sided, after you go through the exponential form, the magnitudes just half and the frequencies invert. Right, so we just end up looking like this. So you have 200 here minus 200 here. Because how it will look when you invert it. It's double-sided. So basically you have positive frequencies and negative frequencies. So the magnitudes will just half. So this will be 5 on 2, and this here will be 5 on 2. It literally just half. CK frequency. And that is the double-sided spectrum. That's it. And you could just write a statement or a sentence stating to go from the single-sided to the double-sided. We just state that the magnitudes will half and the frequencies invert. And they go straight to it. So actually when you do the exponential form, you'll actually see that is actually CK on 2. So that is that. The magnitudes half, and well, we see if it's double-sided, the frequencies will just mirror onto the negative side. So nothing gonna happen with the frequencies. It's gonna be negative now, right? Which is not practical, right? But you will appreciate this more when you do communication systems, which is 2001, right? Right, phase, same thing, single-sided. Frequency, it's, we know what the y-axis is, it's theta k. We have a smoke at 200, it's and it going up to 90 degrees. Or pi and 2. Whichever one you pick to use, don't change it up, right? And that is your phase spectrum. And if you want to go to the double-sided, from the single-sided, in terms of the phase, that is, so I'm gonna just draw a little smaller because kind of cramp the space. The frequency just go and invert. Nothing gonna happen with the frequencies, but the phases will invert. So it will look something like this. So for positive 200 hertz, and you have negative 200 hertz here. For the 200, obviously, you're going to go up to 90 degrees. But for the negative, the frequency, the phase will invert. So you'll end up with it being double. And I double-sided spectrum. That's what it is. So that's going it over. If you want to go from a double-sided, from the single-sided, which is going from the harmonic straight to the double-sided, which you have to go through the single-sided. So here it is. When you do any question and miss after the double-sided, and she never say go through the exponential form, go through the harmonic, sketch the single-sided spectrum, actually sketch it. Show miss they actually sketch it. Then write the sentence, and then plot a double-sided spectrum. Yeah? That is why it does do it. Okay, it will take you less time than going to the exponential form, and then from the exponential form, plotting the double-sided spectrum. So what I had to do, which is what Miss told us to do when I was doing the course, harmonic, single-sided, sentence, double-sided, end of story. Yeah. So to go from single-sided to double-sided with magnitude, the frequency all got involved, right? Because it's a mirror. And the magnitudes half. So if you had 5, it would be 5 and 2 for the two spokes, and the frequency does not mirror, right? This is a double sided. And for the phases, obviously the frequency was still invert, but the phases also invert. Yeah, that's basically quick fire way to just go from the single sided straight to the double sided. You have to start with the single sided. You gotta remember that, right? Okay, so that was the easy one. Just one signal. So assume no questions, continue. And if you have any questions, stop me. Otherwise, I was going to continue. So the takeaway from this question here are these steps. The form, is it in the angle? The sum, spectrum. Go ahead. So I try with another weird looking thing. So this one is have something that I need to pay attention to. So pay close attention and look out for if I'm making any mistakes too, right? Even though I shouldn't. And I shouldn't make any mistakes. Anyway, so 2 pi k, so f naught t plus 45 degrees minus cos 6 pi f naught t plus 30 degrees. All right, so we have two signals here. Okay, no problem. So let's analyze. What form is it? Is it kind of like 80% in the harmonic form, but we will say it in the harmonic form solely because it's just costumes. Remember, it's a sum of individual sinusoids, right? So this here is a sinusoid, and he is a sinusoid, right? So harmonic form, no problem. Second thing is in the 2 pi form, this one good, but here have a problem, so you gotta write it over. So cos, so he good, thanks. So we can skip him. right? Minus cos, factorize our 2 pi one time. Right. So you have that. Good. So we have the 2 pi f naught t or whatever you had there, which is good. So check. Second thing we need, well, the third thing we need to look for is sums. So there's our sum, good, but problem, pressure, any count. There's our minus. So you have to convert this minus cos to positive cos. So basically we had to learn is how can I go from minus cos x, when my x is everything in this bracket, to cos x? How in any route can I go from it? So obviously I have the answer here, but I want to show you how you can actually use Desmos to get the answer. All right, so let's jump to my Desmos. Hopefully you'll see it right now. Let me know if it's not seeing it. Right, so it should be easy. Right, so we starting with what? Trying to say minus cos x. So we at here. We want to get it to overlap, but we had to find a shift that could get into it. So let's go. So we want to get to cos x. So for our bracket, so it's a shift. Let me try some. When you do it using that most, you can't put like 56 degrees, right? You have to express it in pi radians. So if I want to say 90, I have to say pi on 2. So let's be careful with that. Yeah? So let me say plus. Let me try pi. Oh no, I get the answer one time. Well, plus pi is the answer. So you add now 180 degrees to the x. I try minus. For those, if minus, oh, let me see. Minus working too. Okay. So let me try pi and 2. Not working. Let me try adding the pi and 2. Not working. So what we learn, if you want to get rid of a minus cos, or basically just get the minus out of it, you can either add 180 degrees to the x inside the bracket, or you can subtract. Cool. Yeah, so you just learn how to get rid of a minus in front of a cos. All you need to do is add or subtract 180 degrees from it, because it will be the same value nonetheless, as we could see. So don't take my word for it. Take Desmos' word for it. So if you get the question wrong, just blame Desmos or your mathematical error. Yeah? So add it, subtract it, same thing. So we jump back on to our question and we just learn something cool. So what we need to do, so this here, brackets, plus or minus 180 degrees or pi, however you'll learn it. So this is important. So you just know how to convert our mind. So now we could use that and write over our signal. And plus, which is what we wanted, cos. So you have 2 pi f naught. Well, so it's about 3 here. But when you factorize the 2, you get 3. Right? T plus 30 degrees. Now you have to add 180 to that. Because of the rule, so you're gonna put cos 2 pi f naught t plus 45 degrees plus cos 2 pi 3 f naught t 180 plus 30 is 210. Right. So let's be careful the factors and that could trick you up a little. But I'm glad I realized. Nice. So we're here. So cos good, 2 pi good, plus sums good. So we could go ahead and get the spectrum. Yay. So you notice we don't know what F naught is, which is our problem. So let's say they gave you the period of the signal. Right? So sometimes this could give you the period of the signal, and sometimes she may not. If she doesn't give the period of the signal, The spectrum will just be in terms of F naught. So don't get shell shock if you just see F naught. And she didn't give you the period. Because F naught, if you didn't know, F naught is 1 on T. Yeah? Where T is your period. Because it's a periodic signal. Right? So we gotta get the single sided because we starting with the harmonic form, right? So we know this is CK, so there's the magnitude spectrum. We have the frequency here, hertz, and the two free harmonics we have are 1 F naught and 3 F. So let's plot it here. So 0, 1 F naught, and 3 F naught. Nice. The magnitude for the 1 F naught is 1, it's understood. 1. And the magnitude for the 3 F naught, which is this one here, is also 1. And if I wanted to go from the single-sided to the double-sided, the frequencies will invert and the magnitudes will half. Yeah, I'm not feeling like doing that. I should catch that up. But I'll do it for this one until you catch it. Now I'll just stop after a while because you should be able to catch it. So minus 1 F naught, minus 3 F naught, and everything will be halved. So this here will be 0 0.5, 0 0.5, 0 0.5, and 0 0.5. CK, frequency in hertz. Yeah, so that is your double-sided spectrum, double-sided magnitude spectrum, right? And the last one is phase. So I'm just gonna like plot it on one graph one time because I get lazy. So theta k. So what two same harmonics? So 1 minus 1. Now that's plotting the double-sided one time. 3 F naught minus 3 F, right? Remember, this single sided is just your positive set of frequencies, so don't mix it up. I just plot the double sided one time because of time. So the phases we have on the positive side, we have 45 on 210. Right, and then obviously if I want to mirror it, this will be minus 45, and this will be minus 210 degrees. Well, obviously frequency, don't forget to label your axes. And we'll have theta k there already, harmonic frequencies and the scaling of them on top of the arrow. And yeah, that's a phase spectrum, double-sided spectrum. I just combine both of them. Remember, your single-sided is a positive set of frequencies. So just be careful. Yeah, technically, a single-sided could be any side, any single side. But for now, until the going comes, just think of it as the positive set of frequencies, real frequencies, right? Right, so that was that. What we learned from that one is this conversion here to go from a minus cos. Right, so assuming no questions, let's continue. Okay, just watch. Right, so we go into our next one. I fed up Syria. Some, I don't know. Right, so let me see what is the next question on the list. Okay, so this one we gotta learn some this. So f of t is equal to 2 plus 3 cos squared 6 pi f naught t plus 20 degrees plus cos 4 pi f naught t plus 40 degrees. Okay, so going through the analysis, this here is a DC component. There's a A naught and 2, 2. But we don't need to touch them. Yeah, so for now. So let's go through. So everything is not in terms of costs, because what is square doing here? The problems. He in terms of costs, so be good. But he have a cost square. That square is a problem. So we had to get rid of this cost square term here, right? So we had to use our trig ratio, right? That's the only way that we could get rid of the cost square, right? That is one of your components. So it's cos squared x, 1 plus cos 2x, all divided by 2. Or how I like to do it is write the half on the root of it. So it'll be a half plus cos 2x, and a half that 2. Right? They will just make doing the derivations easier. Because with the 2 at the bottom and everything, you could just get cumbersome very quickly. So this is what we're trying to use. And if you notice, it's in terms of costs alone, which is what we want. Right? And then I'll just write the sign one time. So if I had a sine square, it'll be 1, same a half, minus a half cos 2x. So okay, that's how I remember it, right? So when you have sine, once you remember the form, the plus and the minus just confuse people. So obviously anybody can memorize half plus 2x, half plus 2x. So when it's sine is n with a n. N means negative. So the sign will be negative. Just remember that. Obviously the other one will be positive. So once you remember the general form is a half cos 2x. If you're using the sine form of it, sine n is negative, so it will be the negative. And by default, the other one had to be positive. You have to memorize two things, right? So obviously for this question here, we have cos squared, so we're using this form, right? So we look to go through. So that's what I like to do is group it. So do them one by one. So when you have like multiple things you have to do, so do them one by one, put it back together, and then get the spectrum. Okay, it can get kind of confusing quickly. So just work it one by one. So I like to circle it and put 1. Then come down here and write 1. So this one know I'm dealing with 1. So I have 3 cos squared, and that is 6 pi f naught t plus 20 degrees. Okay, so I go through this. So you want to get it in terms of cos 2x. So I like to do this angle here, writing this over and over and over in our proof. It's a lot of work. So we could say let 6 pi f naught t plus 20 degrees b y a b c anything you want it to be. Should really matter. There are like 26 letters in the alphabet. So now we're just dealing with cos squared y, which is way easier to work with. So we're trying to get into this form. So you just use the equation off the back. So we had the tree, but the tree was there already, right? We're trying to rewrite this piece here. So the tree will stay, big bracket, a half, cos, the sign is the negative, because the sign at the end. So this one had to be plus cos 2y. Yeah, that's right. So now all I gotta do, expand. So 3 and 2 plus 3 and 2 cos of 2y, right? And you finish, break it down, and it just plug back in y, which is why I did that before. Because right, and now over and over is too much. So we cos 2, right back in y. Right, and now because there's 2 here, you can just factorize it out. So the final form of it will be 3 and 2 plus 3 on 2 cos 12 pi f naught t plus 40 degrees. The final thing I had to do, this 12 had burning my eye, right? So I could finally factorize it. The reason why I didn't do it before is I will make the derivation more complicated. So I just go through the whole derivation, get it in terms of cost, and it's in a form that I custom putting all the two in. So I could just do it one time and finish with one. So that'll be 2 pi 6 f naught, and I'm making a mistake again, t plus 40. And that is the end of one. So basically, what we learn is the trig ratio, how to convert cos square into just cos cos, right? So you just memorize the trig ratio, which is this here. Pull it out. My advice is to let everything in the bracket be a letter, because if you had to write it over and over and over and over, it could get cumbersome over a period of time, right? So just let it be a letter, work with the letters, and when you finish the derivation, write it back in. Simplify. So in this case, I'll let this be y. I'll work my tongue, my thing. So cos square y, plug in the trig ratio, you expand your little bracket, because it had a number before. And then I finish here now. So I'll plug back in my y, which is I got this here. Make sure I'm paying brackets, expand on the 2, and then I could finally factorize the 2 to get it in the form that I want it to be in, right? And then I check everything positive, so I'm good, right? So type 1. So when you're doing writing over the whole thing, you gotta just write it back over. So basically, you're done. Huh? I don't want to do too much in this question. This already here, so we can rewrite everything. We gotta factorize 2 out of this. So I just rewrite the whole thing and plot the spectrum. So we had 2 plus 3 on 2 plus 3 on 2 cos 2 pi 6 f naught t plus 40 degrees. And then the last one was cos 4, so cos 4 pi f naught t. So that'll be, if I factorize the 2 pi out of that, that'll be cos 2 pi 2 f naught t. And what the angle was, 40, right? Both of them, okay, at 40 degrees. So let me make sure I'll take down both of them correct. 40, 40. Right, so obviously now we could group like terms. So this, we could bring this together. So here we go here, calculator. So I am not doing that in my head, no matter how good I feel I is in maths. So 2 plus 3 and 2, 7 and 2. Okay, calculator say so. So all right. So plus 3 and 2 cos 2 pi 6 f naught t plus 40 degrees and plus cos 2 pi 2 f naught t and plus 40 degrees. Right, so we have 4 little more legible. Right, and we're done. Right, so you have everything plus, which is good. It's in harmonic form, good. Cos, nice. 2 pi factorize, everything fine and dandy. So this says a DC component, right? So I'm going to show you all how you'll represent it. And this question is the last question I put in the spectrum for, right? Everything from here just doing the tricks. So you have 0 hertz. So your DC component occurs at 0 hertz. Why? Because DC has no frequency. So it's 0. Yeah, so that is the answer. If you wanted to know why, a DC components have no frequency. If you remember from a BJT with a capacitor is a frequency dependent device. So if something passing through that doesn't have a frequency, it would just act as an open circuit, right? So I don't know if I remember, see if I remember. J. So F is your frequency, right? So if your frequency is zero, you just go and get, and this is ohms, your resistance, right? If your frequency is zero, you just go and get a open circuit, so no current can flow through that. Because almost like if you have infinite resistance, okay, that's gonna end up with one divided by zero, because the frequency is zero, which is infinity. So it's basically an open circuit. So it just gonna block the DC, yeah, because a capacitor blocks DC. But if you're working with something with a frequency, which means F is not zero, it's actually a big number. One divided by a big number is a small number. So which is why a capacitor, it will act as a short circuit to AC, but it will just act as an open circuit to DC. And that is because the frequency is zero. Yeah, so zero. Do not put your DC at any other thing because you will lose max. We don't want to lose max. So let's go through. So 7 and 2 is a DC. So that will be at 0, 7 and 2. Nice. So the next one is 6 F note. So I plot the double sided one time. And that going up. So going up to 3 and 2. So you have to half that. So it'll be 3 and 2 divided by 2. So you have 3/4. Okay, yeah, that makes sense. Because like 1.5 divided by 2. Right, so then the other one is at 2 F notes at a magnitude of 1. So that'll be right here. Okay, no problem. And if it's 1, you have to half it. So it'll be 0.5. Yeah, well, label the axes, obviously. Frequency, it's CK, and that is your magnitude spectrum. And the phase at DC doesn't have a phase. Yeah, at DC doesn't have a phase. Well, at least at this level in this course. The DC don't only have a phase. Alright, so do not write anything by the 0 hertz for a phase spectrum. Right, that is the easiest way Mr. Ketchup doesn't have a phase because it's just strictly just a magnitude. Just a magnitude. Right? So that is 0. So at 2 F notes, it was 40 degrees. Well, both of them 40. So, so positive is 40 degrees when you invert it, minus 40. And at 6 F notes, it's 40. And at minus 6 F is minus 40 degrees. And that is your phase. Yeah, that is it. That is basically it. So I think you're kind of catching, you're always trying to work it to the harmonic form. Like the form you kind of get spectrum from. And from a single sided, you get the double sided. Same thing over and over. Right? So let me try, I'll try two more. I'll try one more. That's one more. I think again, you're late. Right, so I go through the sun, we bust out. Somebody had to go out. So this one I have the two things that I want to do in one. Right. So let's see. So two, skipping that. 6, 5, F naught T plus 40 degrees minus 2 sine 4 pi F naught T plus 10 degrees. Okay, so this one have a lot in it. Sorry, let's start one more sentence. All right, nice. So we have this question here. So we go through our analysis. Steps, everything in terms of cost? No. So let's handle that one time. So we have cost cube here. So here's our problem. So I will normally circle it and put number 1. And the first thing on the hand. This here, in terms of sign, so he forward and it have a negative. So he problematic and he own. So we get label that two. This one here, it in terms of cost, good, but it have a minus. So ugh. So we had a handle. He really need a number, but he have a cell number. Just so mistake, but so he will know it train at all. So that we handle one. So one is our trig ratio, obviously, right? And the trig ratio for cos cube, right? So it's cos cube x is just cos 3x plus 3 cos x. Obviously, I don't like to put it all over 4. So it'll be a quarter there, and this will just be over 4. I try to like this. Everything over 4, but when you're doing the actual question, having everything over 4 just complicates it as you go on with the proof. So this is it. This must, if must bring out cos 4x, she wicked, right? So she wouldn't bring anything higher than 3. Highly though, because I real trees. I'm not sure you what I do for that. Hope you won't take too long. So if you have cos 4x, I'm not sure you the mad thing you have to go through this, right? You gotta split this into cos square x and a cos square x. And you gotta multiply them two together. So you see that cos square trig thing that we learned before with the half plus a half cos 2x and then the half plus a half cos 2x. So you had that. Now we had to go and multiply and expand this bracket up. And then when you expand that bracket now, you're going to end up with a cos 2x by a cos 2x eventually. So then now you have to go and do a next compound angle with the cos, then to go back again. That is pressure to do in an exam. Yeah, she will not bring that. If it's a midterm, she bringing this, you're going to take at least 5, 6, 7 minutes just to break this down. Fault if she bring more than 4. So she will keep it at Q. If she bring this, it had to be for a final exam. And this question had to be like for 25 marks or 30 marks or so. Because just breaking this down would take a while. Because you had to expand this brackets. Some of them will be a half cos 2x, all good and well. But everybody could clearly see that you're going to end up with this being multiplied by this again. So that is too much. It's just too much. So keep up to cos cube and just keep your fingers crossed that the still being costful. But I mean, if you want to, you could try doing it with the costful using the cos cube, so cos square, sorry, the two cos squares, breaking them down, expanding it back, and doing the compound angle again to get down, and see how long it take you. And you can always message me if it meets a part that's kind of looking weird. But anyway, let's get to this. So we have 1. So we have 4 cos cube, and I can just let this inside here be A, right? So this here is A. So be cos cube A. Okay, so I could just use this. So we're trying to get rid of this here, right? So that would end up being 4 open brackets, big open brackets, quarter cos 3A plus 3/4 cos A, right? So expand the brackets. So 4 by 4, you get up with cos 3A and 4 by 4. Well, I mean, luckily for us in this case, it cancels. Let's see enough of that. So now we could finally plug back in the A. So what the A was 6 pi f naught. And then plus 3 cos 6 pi f naught t and plus 40 degrees. Right. So all I had to do now expand out, and obviously you're seeing, you should be able to see it by now. That you're kind of missing the pies. So let's go through. So factorize the 3. So 3, 3. So you end up with 18. And that'll be 120 if I'm not mistaken. Plus 3 cos. And we could pull out the 2 out of this one time. Alright, so pull out the 2 out of this. And we on our way. Because that's 9. And plus 3. And right back where we had before. Okay. So that's the end of that. Chalala we went through there. 1 is complete. So 2 now. So we have a bit of running away, running around we had to do with this. So we have a sign and we have a minus. So what I like to do is convert the sign to cos and then use the minus cos to get positive. So I go through. So 2. So we have minus sign of what is 4 pi f naught plus 10. Okay. 4 pi f naught t plus 10 degrees. So we'll want to convert this sign to cos first, but we don't know. We struggle because we never do that. So how we gonna know? Decimals. That's the best way. Straight to the decimals. Get into the habit. So go across the decimals. So where we starting from? We're starting from sine. That's sine. So put in minus, that's it. How do I reach it? Sine x. That's start with the sine x. We know what to do with the minus. We know what to do. We're trying to get the sine to cos. Yeah? So we see. So we're gonna end up in cos for our brackets. So it had to be a shift. Well, let me try adding pi. That didn't work. Subtracting pi. That did not work. Let me try pi and 2. Ooh, voila. Let me try plus for good measure. Let's see if it gives us anything different. So now, the plus don't work for this one. So this one, it don't have a plus or minus. Because the plus giving you this kind of inversion, but the minus giving you the perfect overlap. So what we just learned is if you want to convert sine x to cos, you subtract 90 degrees or pi and 2 from it, from the x. Yeah, and thank you, Desmos. So we subtracting for now. All right, so I go back and do what we learned. So we do them with this for now. That's this for now. Forget about the minus. We know what to do for the minus. So you have minus cos. Remember, this entire thing here is like x, right? So that's not confused. So it's 4 pi f naught t plus 10 minus 90. Pi and 2 is 90. So I'm going to write pi and 2. It's not going to confuse me because I already have it in degrees, right? So again, I put minus cos of 4 pi f naught t. 10 minus 90 is like minus 80, I believe. Okay, so now I could finally handle the sum. So obviously is a minus. And we learned before how to convert a minus to positive. You can either add or subtract pi, which is 180 from. So I guess I can add. It's the same thing, it really matter what direction you're going. So we finally end up with the cos. 4 pi f naught t minus 180 plus 180. It really matters. So finally end up with where you want. So minus 80 plus, so I think 100. And we could finally factorize it. I like to do that for part last after I do what I've got to do. Right. So, all right. So during the proof, just to make sure that you get accustomed to write it. Every time you use like a law, just write it up. So the law that we learned there is if I want to go from sine x to cos, I have to subtract 90 degrees. That's what we did here. To go from the sine x to the cos x. And then to get rid of the minus, which I think was here. So you have minus cos x equals per r. That would just be, you either add or subtract pi, and that's, yeah, that is basically it is. It's not too much to say. So plus or minus 180 or pi, whichever way you give it. That is it. That way you use. So which write down where you use. So I should know like where you're going. Because it has error carry forward. So if you know, hey, she give you give her your trig ratio where you're using and you make a little mistake, she'll get your marks. Because you know where you was supposed to do. Yeah, that's make a arithmetic mistake. But anyway, if you think we're done, we're done. So you can see why the question now. Alright. So we just break down two. So what one have? I don't think one had much in. If there's a minus, we could we write already. Just add 180 to so it'll be plus cos. I already had the 2 pi. So it kind of help us out. Right? And I end up plotting the spectrum for this. Remember? So one, where we end up with one. At the end of one, we end up with harmonic frequency 9f naught, phase, and the magnitude is 1. So at 9f naught, you have a magnitude of 1. If you express it in the double-sided, is 0.5. Same thing for 3. With 3 and 2 for double-sided, 3f naught or minus 3f. And 40 degrees is your phase. Okay, probably catch the drift by now. And for 2, we end up with just 1, which is just this here. And we roll with that. So we had to go from sine to cos and minus cos to sine. That is always the route. So if you have a minus sine x, let's break it down for you. So you go to minus cos, and then from that go to cos. That is the best way I can break it down. Technically, you can do it in any order. I like to work, get the cos first and then swap to so that get the minus. And then have it. So, I mean, I guess that way could make it easier. But, I mean, it could go from that to the sin x to get rid of the negative first, and then just go from the sin x straight to the cos x. That will work too. That, no problem with that. This is what I does use. Either way, you get the same answer as you notice. Same thing. So at this one, 2f naught, phase is 100, magnitude is 1, double sided is 0.5, and the phase will inverse. Kind of break behind the back with that. And when the last one was phase 180, this, the harmonic frequency for this is 1f naught, and well, the magnitude is 1. 0.5 is double sided. All right, let's see what the next question is. Yeah, I think, well, the next question is just using the sine square, which is the sine square is this one on top. I think I wrote it. Yeah, this one. So if I use the sine square, it have one extra step because you notice you have a minus there. So you had to invert, you had to shift this after. Yeah, that's what I wanted to do in that question. Because in the minus, you had to add 180 after you do your chalala, you have to get rid of the minus. That is the only little trick with this one here. Right, and the last form is just your compound angles, but the compound angle questions, once you know your compound angles, you could attempt, okay, just trying to use the form that you could get cos from, because that's where you want to go to. But that is for our next week conversation, because almost 9 o'clock. Right, so with that said, that is the end of class. I went through everything I wanted to go through with you all.